CQDX, CQDX, CQDX. This is Havana calling. CQDX, CQDX, CQDX. This is Radio Havana calling all shortwave listeners and radio amateurs. Welcome to... DXers Unlimited, Radio Havana's weekly feature dedicated to the fascinating world of radio communications.
Hola amigos radio aficionados all around the world, and a special salute to those of you that live in the northern hemisphere and listen to this program. The weather patterns are now evolving into the typical winter conditions, better shortwave propagation indeed. I am Arnaldo Anicoro, your host here at DXers Unlimited, the radio hobby program that is our station's contribution to the promotion and development of the radio hobby in general, and especially aiming at helping all of you, everyone, to become a licensed amateur radio station operator and enjoy that particular aspect of our wonderful hobby, amateur radio, ham radio. Now here's our first item for today's show. It is weather related and has to do with some very interesting propagation conditions that make possible long distance signals to travel when certain weather patterns do happen. It is a well-known fact that TV and radio signals that make use of certain frequencies of the radio spectrum can be affected by atmospheric conditions. That's simply very well-known fact. And those atmospheric conditions include high air pressure, which brings fine weather and very interesting propagation patterns. Terrestrial television and FM band signals may be disrupted severely during episodes of very high pressure, atmospheric pressure, that may sometimes last up to several days in a row. In the case of terrestrial digital television broadcast, this may result in temporary picture breakup, known as pixelation, or you might suddenly find that it is possible to receive signals from outside of your service area of the digital TV transmissions. On the FM radio, this may result in weak signals or complete loss of service, or some new stations appearing on your dial for brief periods. Broadcasters can't do anything about it. They can prevent it. And adjusting your antenna will make no difference at all, and you will find that the system will only improve when the weather changes. Then things will come back to normal. High pressure atmospheric conditions, they do influence a lot propagation. Weather-related interference occurs mostly in the summer months, when periods of high pressure can cause radio waves from distant transmitters to travel further than normal, which can result in interference patterns. The diagram of the sun hitting the ground and the warm air getting trapped between the cold air explains everything. When this happens, it creates a layer that mirrors the television signals, and they make it propagate far away. It is not possible to exclude completely interference due to the weather, but broadcasters do their planning on the basis that viewers and listeners should be free from this sort of interference problems for at least 99% of the time, providing they live within the service area, the actual service area of their transmitter, and are using a good directional antenna system. Since we cannot control the weather, we have no influence over abnormal propagation through the troposphere, and it is only practical to plan a network where interference is suffered no more than 1% of the time. That's most of what you can do. To improve on this figure, broadcasters will need to increase the number of transmitter sites drastically and build a much denser network. It will cost a lot of money, so it's impractical. This is, as I said, impractical and will be very expensive. Add to this that, unfortunately, tropospheric type interference never spreads thinly through the year. It tends to happen mostly during the evenings when television viewing is at its peak and specialist FM programs are on the air. It often appears at the same time on consecutive days, then disappears for several months, and then happens again at random. Some years are worse than others, depending on the prevailing weather patterns of the particular year. Just to give you an idea of the dependence on terrestrial signals for television broadcasting in the United Kingdom alone, there are over 1,000 television transmitters sharing the UHF TV frequency bands. In Western Europe, where the same channels are in use, the number of television transmitters most likely exceed 30,000. Similar congestion occurs within Europe on FM radio frequencies. Neighboring countries must coordinate their networks planning so that mutual interference, even during periods of abnormal weather patterns, poor propagation, is kept to an absolute minimum. It is impossible to plan a network which is totally free of interference, but broadcasters can protect the transmitter service areas for the majority of the time. This can be achieved by very carefully choosing the channel groups and aerial polarization used at each station. Additional protection can be obtained by using directional antenna systems at the transmitter site where necessary, and by using natural features such as hills and mountains to maximize the installation coverage. In the case of UHF television, transmission frequencies can be offset slightly to minimize the subjective effect of possible interference, especially on the analog television. Last but not least, network planning assumes that the viewer or listener will fit a good antenna to keep out unwanted signals arriving from directions other than the wanted signal comes from. More about weather-related, very interesting events that enhance VHF, UHF, and microwave frequencies coming up after a short break for Station ID. I am Havana Cuba broadcasting from Cuba. This is Radio Havana Cuba. The name of the show is DXers Unlimited, and we continue now with more radio hub-related information for you. Let's learn more about the phenomenon known as nocturnal inversion. This type of weather pattern can occur after dark if the land cools more rapidly than the air above it. During the daytime, the sun heats both the ground and the air, and there is a normal fall of temperature, and the refractive index of the atmosphere with height changes. In the evening, the ground cools rapidly, and the layer of air closest to it becomes colder than the layer immediately above. Around dawn, during the sun coming out, the air in contact with the ground is at its coolest and may also be very moist, resulting in the presence of fog or dew, a telltale that a propagation event may be in progress. As in the case of the inversion, the sharp contrast between the two layers of air, one cool and foggy, the other warmer and drier, provides the right conditions for long-distance propagation of VHF, UHF signals, as many radio hubs know when using the 2 meters and 70 centimeters bands and also the microwave bands. Nocturnal inversions occur exclusively over the land, as the ground can cool much quicker after sunset than the sea. And here is now my little piece of advice for TV DXers, those of you trying to pick up distant television stations. If you have tried auto-tuning your television receiver, this may help in finding distant signals that only reach you when a temperature inversion is in progress. Yes, amigos, to my friends, TV DXing is, in the days of terrestrial digital television broadcasting, opens up a new and fascinating and challenging area of our hobby that will require learning about the high-gain UHF directional antenna system, low-loss coaxial cable down leads, expensive they are, but they are needed, and mass-head low-noise preamplifiers that, when properly installed, will provide you with the highest possible probabilities of watching long-distance terrestrial digital TV broadcasts. And now, our next Radio Hub-related news item here at the weekend edition of DXers Unlimited, coming to you from Havana, Cuba. The topic is related to recent, very interesting 10 and 12 meter band amateur openings that have surprised regular users of the frequency region between 24,890 and 24,990 kilohertz. That's the 12 meters amateur band, and between 28,000 and 29,700 kilohertz. That is the 10 meters amateur band. On 10 meters, we have the advantage of counting with the 24 hours a day on-the-air amateur radio beacons. Very, very good. Send signals using automatic CW Morse code radio telegraphy, signals that are sent at low speed, easy to pick up, so it's easy to decode them no matter your slow speed of reception of the Morse code. You can then copy the calls by listening to the beacon signal, and then you will know from where they're coming from. On the 12-meter band, there are just a few beacons because of that band's small bandwidth of only 100 kilohertz. During solar minimum years, the ones we're going through right now, ham radio activity on the 12 and 10-meter band goes down dramatically, but there are still many unusual propagation events that are quite useful to work the stations by radio amateurs all over the world. My advice for every radio amateur that owns a 12 and 10 meters band capable station is to install a simple dual band dipole fed via balloon and 50 ohms coaxial cable. The 12 meters band and the 10 meter band half-wave wire dipoles are connected in parallel at the feed point and are kept separated by using fiberglass rods cut to a length of about 20 centimeters that separates the two from each other. The small antenna system that you can install at locations where space is at a premium, and some enthusiastic 10 and 12 meters amateur operators also advocate for the installation of a second antenna, a dual band quarter-wave vertical using 4 sloping radials that at the same time form part of the mass support system. And by the way, the support footprint of that small dual band vertical is even smaller than the area required for installing dual band horizontal dipole antenna that I have just mentioned. Again, Again, if you happen to be a licensed radio amateur operator that have equipment capable to operate on the 12 and 10 meter band, go ahead and install your antennas for those two bands and start monitoring them for DX signals. They are there quite frequently. I'm sure that you will enjoy many nice DX contacts during the months of November and December when propagation conditions are better. And now I'm going to tell you that the solar activity is at very low levels. Solar sunspot number 0 for 3 days, 71 days of the year 2017 without sunspots, that's 23% of the year, and the solar flux at 73. See you all at the weekend edition, see you all at the upcoming middle of the week edition of DXers Unlimited, and then it will be possible for us to get together again and learn more about Radio Havana that is so relevant to your pastime. Please send your signal reports and comments to info.rhc@enet.cu or via email to Arnie Coro, Radio Havana Cuba, Havana, Cuba.
And that's all for today. This is Arnie Coro, Radio Amateur CO2KK, your host here at Radio Havana's DXers Unlimited, saying 73, very good DX.
DXers Unlimited heard every Sunday, also on Tuesdays here with Arnie Coro on Radio Havana Cuba.